Hello, this will be our second video on Laplace transformation. I'll continue making some of the other proofs that we started in the previous one. Okay, let's say that I want to prove that Laplace of sine 80 equal a over s squared plus a squared, but still here you have another hint that says that sine 80 equal e to the power of I80 minus e to the power of minus I80 over 2i. Okay, so now instead of this sine 80, I'm going to plug in this value, which is Laplace of e to the power of I80 minus e to the power of minus I80 over 2i. So I'm going to find out what's the Laplace of this value. First thing, I can take out 2i as a constant number, and I will be left with e to the power of I80 minus e to the power of minus I80. Next thing, you can distribute this Laplace for both values. Okay, once I distribute this one, I can find what's the Laplace of this value and this value by going back and reminding that Laplace of e to the power of 80 equal 1 over s minus a. So here, in case you have a coefficient for the a, which is I, this I is going to be added here. So this will be 1 over 2i, 1 over s minus I a, minus 1 over, okay, here if you have a minus, here you'll have another minus, and minus with minus will give you plus. So this is going to be 1 over s plus I a. Good. Now the next step will be making this as a lowest common denominator, and still I'm going to use here the difference between two squares. It's going to be s squared minus I squared a squared, because I times I will give you I squared and a times a will give you a squared. And here for the numerator, here you're going to have s plus ia minus s minus ia. Good. Now I'm going to make it more simpler. Please try to remember that I squared equal negative. This is an imaginary number, so here this negative is going to be changed to positive, because I squared means negative 1. So negative with negative will give you plus. So it's going to be s squared plus a squared. And here I'm going to open the bracket. Here we'll be left with s plus ia minus s plus ia. Okay, good. So now what are the things that I can cancel out here is s with negative s, and you're going to be left with 2i's over s squared plus a squared. Now you can cancel out the 2i with the half of 2i. So what will be left is a over s squared plus a squared. So we already have proved here that Laplace of sine 80 equal a over s squared plus a squared. Good. Now we're left with the last proof of this type, which is a Laplace of cosine 80. So Laplace of cosine 80 equal s over s squared plus a squared. Again, here we're going to use the hint that will make this proof simpler, that cosine that cosine at equal e to the power of iat plus e to the power of minus iat over 2. Let me make this one more clear. Alright, now I will start to prove. Instead of this Laplace cosine at, I'm going to plug in this value. So you're working for the Laplace of e to the power of iat plus e to the power of minus iat over 2. I think that by now you are already familiar with the steps I'm doing. I'm going to take the 2 out as a common factor, and I'll be left with Laplace of this. Okay, so once you reach this step, you're going to distribute this Laplace for both Laplace of iat plus Laplace of e to the power of minus iat. Good. Don't forget that Laplace of e to the power of at equal 1 over s minus a. So here e to the power of minus iat, here if you have an I, you have an I here again, so it's going to be 1 over 2, 1 over s minus a plus 1 over, here if you have a minus, this is going to be changed to plus because there are going to be 2 minuses, will give us a plus ia here. Now I'm going to go for the least common denominator, which is s squared minus I squared a squared, and here s plus ia plus s minus ia. And please here don't forget that I squared means -1, so this negative is going to be changed to plus because I squared equal -1. So it will be s squared minus with minus going to give me plus a squared. Here I'll make it simpler. Minus ia and plus ia will be cancelled out, and you're going to be left with 2s. 2s, because here you'll have s plus s, which will give you 2s. I can cancel this 2 with the half, and I'll be left with s over s squared plus a squared. So here is the proof for Laplace cosine at equal s over s squared plus a squared. Okay, I'm done with these proofs. In the next videos I'm going to give you examples of finding a Laplace transformation for some functions. Hello, in this video I'm going to do for you Laplace transformation examples. Okay, let's say that our first example is find the Laplace transform of f of t equals t. Before I go to this example, I want to remind you of some simple ideas here. E to the power of negative infinity equals 0, e to the power of 0 equal 1, and don't forget the integration by part, which is u times v equal integration of u dv plus integration of v du. I'll need this 3 notes in the next example, so I'll start to solve or to find the transformation of f of t equal t. So it's going to be from 0 to infinity. F of t is t times e to the power of minus st dt. Alright, here we have a problem. You cannot just integrate it simply, because here you have two functions related to t, so you need to do the integration by part. I will call this u and I will call this one as dv. So if you have uv equal integration of u dv minus integration of v du. Here what do I have? I have integration of u dv, integration of u dv. So I have this one. So bring this one back. Integration of u dv equal uv minus integration of v du. I brought this one back and make it here minus. So here I know du and I know dv, but I still need to know what is v and what is du. So u du and v dv. This is v, but I'm writing it this way so that you understand that it's a v, not a u. Anyway, here what are the values that I know are u, which is t, and dv, which is e to the power of minus st dt. So if u is t, du will be dt, and here dv is e to the power of minus st dt, so v is going to be e to the power of minus st divided by negative s. I think that this is clear, so I'm going to plug in this one here, because integration of u dv equal uv minus integration of v du. So what is u? U is t. u v. What is v? V is e to the power of minus st over negative s. I'm done with the uv part minus integration of what? V du. Again, what is v? It is e to the power of minus st over negative s du. Du is here dt, and it's an integration from 0 to infinity. Don't forget that. Good. So now what would be the next step here? I will leave this one as it is from 0 to infinity minus this one. I can integrate it simply because it's a one function. It will be e to the power of minus st over this negative s will go down to be multiplied, so negative s times negative s will give you s squared as a positive from 0 to infinity. Now here I can start to plug in these values of infinity and 0 instead of the t. So if I start to plug in here, instead of t, first thing you'll have infinity times e to the power of minus s times infinity over negative s. So I'm done with the infinity part. Now it will be minus, instead of t I'll put 0 times e to the power of minus s times, instead of t you'll have 0 over minus s. Now I'm done with the first part. Let me go to the second part. E to the power of minus s times what? Infinity over s squared minus, now I'll go to the 0 part. It will be e to the power of minus s times 0 over s squared. Good. Now I'll start to see what will happen after this substitution. Of course, 0 times anything here will be 0 divided by s. Again, the whole part here is going to be 0. The whole part is here 0. So, and here e to the power of minus s times infinity, that means negative infinity. So this is going to be 0. 0 over ss, again 0. Negative multiplied by 0 will give you again 0. 0 minus 0 doesn't make any sense, so this part is going to be considered as a 0. Minus, now let's talk about this part. Negative times infinity will give you again a 0 here. 0 times 0 divided by s squared is 0 again. So 0 minus s times 0 will be here 0, and e to the power of 0 is 1. So 1 over s squared. These two negatives are going to give you positive, so the answer will be 1 over s squared. Okay, I hope that this example was clear. See you with the next example. That's all for today.